Hello, everyone. This is actually my first talk since the start of lockdown, so I'm probably a bit more nervous now than I've been in a long time when doing a talk. So let's hope things go okay. I've got a lot of demos in this talk, and that's always pretty challenging. So hopefully nothing breaks. If it does, I'll just try to talk over it and pretend things are going okay. So we're going to talk about software-defined radio. Show of hands, who has come across SDR before or used it, played with it? Anyone? No, so a brand new topic for everyone. Okay, awesome. So this is one of my favorite areas of cybersecurity. And hopefully in this talk, I kind of show people why, show you the types of things we can do. And hopefully people can play around with some of this stuff as well. So, does anyone know what this is? So yeah, we've got an oscilloscope there. The stuff on the desk though is an ICD, so like a wireless defibrillator. So like to shock people's hearts when they're having medical conditions and stuff. In the past, these devices, they would be implanted into people's chests, and if they needed to be updated, if the software needed to be updated, configuration changes need to happen, they'd have to go back into surgery, get these devices removed, modified and put back in. Then they switched over to using radio, which means they didn't have to have surgery. They could just use like a little controller to change the configuration settings. Which is obviously awesome, right? But now they're moving over to radio, and some researchers have found that they were actually able to, recover details from these devices, so to use them to potentially stalk people that had these devices implanted. They were able to change the settings, to disable the device, or actually induce electric shock on the chosen target, which, I mean, people can imagine how dangerous that can be. And people walk around with these things in their chests, and any attacker could come along and just shock the person using it. Cars have lots of radio devices in them. If we take like a modern car, we've got the keyless entry, right? There is the braking systems can use radios. Obviously, there's the radio in your car for listening to music. There's airbag stuff, like all these radio devices that are inbuilt into cars now to make people's lives a bit easier. And researchers were able to take control of some of these systems. So they could do things like enabling the brakes on a car by hacking the radio devices that were attached to the system. They could display their own text in the speedometer. Like all these new attacks that are taking place by attacking the radio systems attached to the car. This is actually one of my favorite radio style attacks. This is called Van Eck phreaking or Tempest. With this, you're tuning into the unintentional transmissions that all electronic devices give off. So through the cable, this HDMI cable, for example, electricity is flowing. And from that, it's emitting basically the data that's going through the cable. Now, it's very low powered. You can't really easily tune into it. But if you've got the right hardware, you can actually listen to that signal and display what is going through that cable. So from across the room, you can have an antenna pointing at the cable or the monitor and be able to recover the image of what's happening on the screen. And if you are interested in kind of more about that, I did write a blog post where actually I used some of the SDR stuff that we're looking at today to perform that kind of attack. And as you can see on the monitor that we have there, I've just got a web page, and then on the laptop, using the antenna that's in the middle, we're actually able to recover that data and see what's on the monitor. So obviously the monitor in this case is connected to one computer, the laptop is completely separate, and we're just using the antenna to tune into that frequency and see what's on the screen. So just very quickly, who am I? My name's Jay. I'm a pen tester and security researcher. I'm really interested in mobile, like mobile security, so like Android and iOS. I obviously like radio things, which is what we're going to be talking about a lot today, and reverse engineering. If you want to follow Digital Interruption, which is the company I work for, DI Security on Twitter, and then some other accounts. Manchester Grey Hats is a group I run. Now, we've not done anything since the start of lockdown, but usually in the before times, we run monthly cybersecurity workshops. So on like everything from like web application hacking, I did a workshop on SDR. We've done workshops on man-in-the-middle attacks, like all kinds of things. We run CTFs and that kind of stuff. We plan on opening up again soon, really kind of when everyone feels comfortable to be in small rooms with lots of people. But yeah, keep an eye on what we're doing, because I think maybe people in this room might be interested in that. So yeah, this talk, we'll be doing an introduction to SDR. We'll be looking at how we can attack different radio systems. So we saw some examples at the beginning. We'll be looking at how we might go about actually doing some of those attacks. Identifying signals. So devices, when they communicate using radio frequencies, there's lots of different types of ways they communicate data amongst themselves. So we'll be looking at how we actually identify that and analyze it. And then we'll be looking at some common protocols and some attacks that are relevant to them. By the way, if people have questions, feel free to just shout out at any time. So yeah, intro to SDR. So this is a radio, right? Or a diagram of radio. When you're listening to the radio in the car or something like that, this is kind of what it looks like. You have the antenna, it's connected to a number of devices. It will take the radio frequencies in the air, it will like select certain parts of that. You have the oscillator that allows you to tune into different frequencies. And eventually it demodulates the data out of the frequency through the air, takes the voice and the songs, and then pipes that to a speaker, right? These are very cheap to make, very few components. But the thing is, a hardware-based radio like this will only ever do one thing. A FM radio is only ever going to be an FM radio. A Bluetooth chip is only ever going to be a Bluetooth chip. These devices, they're very easy to make, very quick to make, and it's, again, very cheap. So, like, in your phone, for example, you've got Wi-Fi chips, Bluetooth, LTE chips, GSM, etc. Put them all in the one device, really easy to do. But it's only ever going to do one thing. SDR is a little bit different. With SDR, we're basically taking the antenna and we're plugging it almost directly into the computer, right? With this small component in the middle, so the ADC or the DAC. So this is the analog to digital converter, and then digital to analog converter. And that's taking the radio signals through the air, converting them to digital signals and piping it to the computer. And then on the computer, we actually use software to do all this kind of stuff. What that means is we have the ability to turn our SDR and our computer into any number of radio devices. So no longer are we limited by the type of device it is. We can just say like, hey, this is now an FM radio. This is now a Wi-Fi chip. And so we have the ability to analyze the different radio devices depending on the software that we're running instead. So the different types of SDRs. Now this slide is a little bit outdated, but I do have some examples. By the way, I've got a few of these spare, so if anyone, I guess if anyone asks a particularly interesting question and you want one, you can come grab one. So this is like the cheapest type. So this is £10. This is the Rtl Sdr. Very, very popular because they are so cheap. Now, this actually started out as a TV tuner. Right, so if you wanted to watch like TV on your laptop, you could plug this into your laptop, run the TV software, and watch TV on your computer, which is really cool. But somebody realized that the way that it worked is it was using the TV tuning software to do all the demodulation. And they realized that if they change the software, then they could actually get this thing to do more things. It is, it's pretty limited. So the frequencies that it can tune between is around 24 megahertz and 1.7 gigahertz. So it's still a huge frequency range, but not as big as some of the other devices, which we'll see. It can look at 2 megahertz of bandwidth at a time, and it can only receive. Right? So this will only receive data. Some of the other things like the, HackerRF. This is half duplex, so this will send or receive, but it won't do both at the same time. I really like the HackerRF because it is a relatively low-cost SDR, and for a lot of the work that I do, I don't need to send and receive at the same time, so that limitation is not much of an issue. This will let us tune, actually it's lower than 30 megahertz. It goes down to, I think, around, what was it, like 6 megahertz or something, up to 6 gigahertz. So you can see like this thing, the range is like massive compared to the Rtl Sdr. And it can look at 20 megahertz in one go. I don't have with me a USRP, but that's like the kind of the next stage up. That will do full duplex, so listen and receive at the same time, and bigger ranges. With the USRP, you have different like daughter boards and different configurations. You plug them together in different ways, and you have different like options of how you can use it. There are, since I first gave this talk, there's been a lot more devices that have been released, like the Lime SDR and others. So if you are interested in this type of thing, take a look at kind of what the modern SDRs that are out there, and you might find something that is in your budget and also lets you do the things that you want to do. So with SDR, we're also looking at electromagnetic frequencies. Obviously, that encompasses a huge range of things from radio, TV, microwaves, all the way up to like gamma rays, visible light as well. But what we're really looking at is the stuff that's in this kind of radio, TV range up into the microwaves type thing. So that would be like over 1 gigahertz. But we're looking at that kind of range usually. And what is within there? Now, I don't expect people to necessarily be able to read everything here, but just to show, these are the kinds of technologies and devices that are operating within those frequencies. So with SDR, we have the ability to potentially, look at all these different protocols and devices and analyze them and look for security weaknesses. So obviously, some examples: Bluetooth, Zigbee, LTE, GSM, Wi-Fi. These are all radio technologies that we can now analyze a little bit easier using something like an SDR. Also, we have like these more simple devices, right? So like remote control cars, they will just use some kind of radio protocol to control it. Walkie-talkies, I think, are kind of interesting because we can tune into walkie-talkies using an SDR. In fact, we have this wireless microphone. Maybe we'll be able to analyze this in a little while when we start looking at some actual like attacks. Baby monitors are pretty cool because people have those in their homes, not really thinking too much about them. But with SDR, we might be able to tune into them and like listen into some conversations and stuff. This little pink toy in the middle, I think, is really, really cool. So this is called the IME. This was a toy aimed at young girls, right? And the idea was that they have like a little dongle that they plug into their computer or their parents' computer, and they can sit around the house and they can text on it. It will send the signal to the dongle in the computer, send it over the internet, and then their friend will have like the opposite. So it will come through the dongle to there. So kids can like use it to message each other. Then the service that used this device went down. So these these toys were useless. So they were being sold really cheaply on eBay. And then some radio hackers realized that this actually contained not quite a software-defined radio, but more like a software configurable radio. And then they could use it basically to do all these kinds of hacks on devices. So they could use it to open up people's garage doors, for example, by converting it into a garage door opener. So all these hackers then started buying these IMEs off of eBay, and the prices of them shot up. So they became like super expensive. And then people were like spray painting them, making them look cool, walking around and pushing the button and doors were opening and stuff. But I thought that was really cool. Wireless keyboards as well, I think is a really important one because, I mean, most people tend to use wireless keyboards now and wireless mice. With SDR, we're able to tune into that frequency and potentially capture the keystrokes that are being sent over the air, right? Oftentimes they are encrypted, but oftentimes they're all encrypted with the same key. So maybe you're not seeing an A go across the air, but you're always seeing the same, like maybe it's encrypted to like an S or something. So you can convert it quite easily backwards and forwards. So again, with SDR, we're able to tune into all these different things. And then these power sockets here, I'm seeing kind of people start to use this kind of stuff for like home automation. Plug it into the wall, plug something into it, and then use a remote control to enable, disable it, turn the lights on and off, etc. Again, with SDR, we're very easily able to capture that data, that information, and pretend that we're the remote. The same kind of thing happens in home, like alarm systems, especially the ones that you're going to buy just like from the shop. They tend to be fairly insecure and quite easy to control, so you can disable home alarms. And the same with cars. Obviously, you have to press a button, the car unlocks. We now have the ability to capture that data and attack it. And people are using that to steal cars. If you're interested later, I can talk a bit more detail about how that attack works, but people are using that kind of attack to unlock cars and steal them and stuff. So I really like this quote. Security won't get better until the tools for practical exploration of the attack surface are made available. And I think a good example of this was early Wi-Fi hacking. Before we really had the tools to do Wi-Fi assessments, it was very difficult to perform those kind of attacks. It's very theoretical. Then as soon as the tools came to do Wi-Fi attacks, Wi-Fi basically broke instantly. If you want to crack a web network, for example, super easy to do because the tools became available. So what SDR does is it brings the same kind of ease to other wireless protocols. So we can start to attack them in a much easier way, which allows us to assess the security of those devices. So we're going to try and do a demo. It's always a little bit tricky doing demo of wireless radio things because I never know, what signals are in the air and what's doing what, but we'll see. We'll see how it goes and we'll see what we can find. I do wonder if somebody could get me a glass of water from somewhere, because I'm very thirsty. Cheers. So any questions while I set things up? Okay. Does everything make sense so far? We've got a question. Why are duplex devices so expensive? Say again, sorry? Why are duplex devices so expensive? Well, I guess two reasons. One, because the hardware in them is a bit more complex. So they're going to be more expensive than this thing that just does receiving. And two, I guess the people that are buying the devices tend to be more buying for professional reasons, so they can be a bit more expensive. The reason why I like the HackerHub so much is because it was one of the first ones that came about that was aimed more at the hobbyist market. Before this, you're looking at spending thousands of pounds on SDR, and then this came out and said, hey, we can do it for a couple of hundred, and then that kind of adjusted the prices of things generally. But yeah, just because they tend to be more complex and can do more things. The question was, by the way, why are the full duplex ones more expensive? Did I get that right? Yeah, cool. So what do I need? I need a USB cable. Actually, I guess if we'll start with the Rtl Sdr. Because we can still do quite a lot with this. Although this is a new one, so I hope that it works okay. So, okay, so this software here is called GQRX. There's lots of different versions of this. There's SDR Sharp for Windows and other tools. But this is the one that I like. So this basically allows us to use the device. If we press play, this might be difficult for people to hear, especially on stream. I don't know if this is going to be picked up on the stream or not. But we turn the device on. We can press play in GQRX. And what we have here is the frequency that the SDR can tune into. So let's go down as low as possible. So 23 megahertz. And if we, so what this is like is, I don't know if people have ever, had an FM radio and they're really curious what would happen if they could keep scrolling up. Because when I was a kid, I was always like, what would happen if I could just keep going up the radio? And that's what this lets us do, right? So let's go to something like 100. So this will be where FM radio is. But because we're inside, we might not actually be able to pick much up. So we can pretty. Let's see. Okay, so there's something, I saw some data there. Okay. I'll switch to the SDR, to the HackerRef. We'll see if we get anything else from there. Because I guess because this is, we're inside a building and stuff, it's going to be blocking off a lot of the interesting things. Okay. Let's try the HackerRef. If not, no big deal, because I've got devices with me that will transmit some data. We can look at that. So I actually have these like wireless doorbells that I bought off from some shop, and we'll see the types of attacks we can perform against that. Okay, that looks a bit better. So we can flash something. That's all right.
We can find. We didn't know if you had a water bottle because we're searching one.
Oh, okay.
There's no free cups per se. So bottle, yeah.
Okay, that's fine. Yes, thank you. So yeah, unfortunately, because we're inside, it's kind of difficult to actually get anything useful in here. But you can see there are things that we can tune into, and if we go up maybe to 2.4 gigahertz. So who knows what runs on 2.4 gigahertz? Wi-Fi, yeah. So you'll see there are some like blips on like here that are coming up, and that's probably Wi-Fi traffic. My antenna probably won't go like up to 5 gigahertz. We might not see anything there, but you can see that there is like traffic that we're able to tune into with this device. I was really hoping we could find some like audio, because one time I was at home playing around with this, and I was like scrolling through, and I saw this like spike. So I wonder what that is. And I clicked on it, and then I didn't hear anything, and then I spoke, and then I heard it through my headphones. So my SDR was picking up something in the room that was broadcasting my voice. I was like, "There's a bug in this room. What the heck?" It turns out it wasn't. The laptop that I was using, for some weird reason, I mentioned about the data that can travel through the wire. Some laptops will transmit the data coming through the microphone just out into the air unintentionally, and that's what the SDR was tuning into. But I was super freaked out. Another time, again, I heard like a one side of a conversation. So I imagine that's probably someone on the phone in a room with a baby monitor or something. We're able to tune into that. But yeah, again, unfortunately, because we're inside, don't really get much. I'm hoping something. But anyway, I would, if people are interested, this is how you would use GQRX, and you can tune into different frequencies and see different things. So this doorbell, for example, I know that's on, well, I think it's on this. So that's on this frequency here. So when I push this, you can see the spike where this is transmitting. All right, does that make sense to people? So we can see the data that's coming from this button that's coming out to this, and we can see it in GQRX. So that's one piece of software, right? So we've been able to use GQRX to analyze the radio frequencies. And again, ideally what we'd be able to do is tune into the FM radio or something, and we'll be able to use GQRX to demodulate that to voice. Actually, I wonder, let's see if we can. Do we know what frequency this microphone works on? Anyone?
No.
No. Okay. But yeah, oftentimes you can tune into these kind of microphones because they're just running on some standard frequency. And if the data isn't encrypted, you'll be able to just tune in and listen into that. And as we'll see later, do replay attacks and stuff. Now this, unfortunately, I don't think will work either because again we're inside. But this is using GQRX to turn the SDR into one type of thing. But there are other pieces of software that we can use that we can change, and then the SDR will be something else. So this is some software called Dump 1090. Now, yeah, we're not going to pick anything up, but aircraft, when they when they're flying through the air, they actually broadcast their location, so their longitude, latitude, and flight number. And by using this tool, Dump 1090, we're actually able to receive that data and we can display it. You can then, if you want, map this onto a map or something and see where the aircraft is. People all around the world are capturing this data actually and sending it out to web services. I had this one kid on Twitter was using this data to track Elon Musk's flights, and Elon Musk got really annoyed and tried to pay the kid to stop doing it. but he didn't. But yeah, you can literally sit there with this kind of device and you can track all the aircrafts that are flying by. But yeah, nothing from in here. So yeah, by changing the software, you can do different things. Another one that's pretty cool is you could create what's called an IMSI capture. So GSM, so a slightly older phone protocol. If you set up the device to be an IMSI capture, you can actually capture a lot of the metadata that the phones and the towers use to like communicate with themselves. I won't show that now, so I know it's not going to work in here, but if people are interested later, maybe we can try it outside or something. Get my slides back up. Okay, so in theory, we saw how to like tune into different frequencies and use like ready-made software to turn the SDR into a different like type of radio device. GQRX, 1090, there's IMSI capture software, there's lots of other things. But how do we actually go about like attacking these systems, right? These devices? Well, the first attack I want to talk about is called the replay attack. This is pretty straightforward. Imagine somebody there trying to open up their like garage door with a button or gate or something. They push the button and their keypad or whatever transmits a signal to the door to say, open up. If we're standing there with a SDR, something like the HackerShub, we can actually capture that data and save it for later. Then when we want to open the door, we can just transmit that exact same code, right? So now we've caught it, we transmit it, and the door will open. What I like about this attack is even if the code is encrypted, like we mentioned with the keyboard earlier, it doesn't really matter, right? We don't necessarily need to know what the code means to open the door, but if it's encrypted, but that same encrypted message always opens the door, then we don't need to worry about decrypting it. We can literally just save it and replay it later. There is a protection, I guess, against this kind of thing, something called a rolling code. That means that every time you press the key, the code changes. That could be kind of difficult for shared spaces. So imagine you're like in a like a block of flats where lots of people have a button to open up the gate or something. They're probably not using rolling codes because things would get all out of sync in a couple of days. Cars tend to use rolling codes, but there are attacks to bypass that. You can either try to brute force it if you get what parts of the code is. There are some techniques to brute force it, or you can do like a. Actually, we'll talk about that one in a bit because it's on another slide. With SDR, we're able to listen in on stuff, right? So if there's anything secret going over the air, we're able to tune into that and view it. This is illegal in the UK in a lot of cases. Does anyone remember pages? Right? Maybe you guys are a bit young to when they were in use properly. But pages, right? They are still in use by hospitals and doctors and security services and healthcare and stuff. That's all in clear text, right? So if you have an SDR, you can still tune into paging systems and view that data. Again, it's illegal, so I wouldn't recommend doing it. A friend of mine did it recently, and they saw all kinds of messages like "lady in the park with diarrhea needs medical attention," and another one was "call this number, the password is XYZ." So yeah, some really weird things going through the air. With SDR, we're able to tune into those. So denial of service, a pretty basic one. If we transmit a signal stronger than the device, we may actually be able to stop anything else from sending a message. Like imagine what that would be like in a first responder type thing where someone blocks mobile phones from working when there's some kind of emergency, or from walkie-talkies from working and things like that. So with an SDR, it's pretty easy to perform this kind of attack. Now, with a big amplifier, big antenna, we can just jam all kinds of radio signals. So back to I mentioned about the rolling codes, a way to bypass that. One of the attacks that people were doing is they would jam the signal, right, by performing some kind of denial of service attack. Someone would come along, try to unlock their car. It wouldn't work because the signal's being jammed. The attacker would start capturing data. The person that owned the car would push the unlock button a couple more times. The attacker would then replay the first code and save the next code in the list. And so then another date they could go to the car, replay the second one they captured. So by using the denial of service attack and the replay attacks, they were able to bypass the rolling code protection. And then another attack that I think is pretty cool is fuzzing. So with fuzzing, we basically send random data to a device and see if we can get it to crash. Usually, when we're looking at fuzzing, we're kind of limited to the application layers type stuff, because we're not able to necessarily modify the actual traffic that's going through. So if we wanted to fuzz something with Wi-Fi and we're using a Wi-Fi chip, we don't really have any control to actually change the bits that are going through the area, the physical layer. But with SDR, we're able to do that. So we can basically just send ones and zeros to a device and see if we can get it to crash or behave in interesting ways, which oftentimes can lead to vulnerabilities. So let's try another demo. What I want to try and show is a replay attack against the doorbell, right? So we're going to see if we can capture this signal, and then if we get the doorbell to ring without pushing the button. So for this one, I'm going to need to use the HackerRF because, as I mentioned before, the Rtl Sdr doesn't transmit. We need to transmit with this. So there's lots of different bits of software to perform this kind of attack. I like to use this one called GNU Radio Companion. And what this allows us to do is to use these nodes to create the software for the SDR. It's quite easy to do. So I've created one before. So when these grayed out ones are not going to be run, but I just have them here for kind of ease here. So I'll keep this one disabled for now. So what we have here is we have the Osmocom source, right? So that represents the SDR, the HackerRF in this case, and then the GUI sync, right? And that is the graphical visualization of the data. And you'll see if we press play, hopefully. Oh, and I've set it to 433 megahertz, which we saw in GQRX. That was where when I pushed the button, that's where the spike in data was. So we've set this on the Osmocom source, and that's piping the data to the GUI sync. So if we press play, assuming that it works. So what we have here, right, so you see it's taking the data from the SDR, and it's just piping it to a graphical thing. And we have different views here. Now what you'll see is this is basically the same as we had in GQRX. It's just displaying the data. And you'll see, again, when I push the button, we see this is the data transmitting from this. Really annoying. So this is the data that's being transmitted from the button that we're pushing, right? So we've taken it from the SDR, we've piped it to the graphical interface. What if we change that instead to pipe it to a file sync, right? So what that will do is it will take the data from the SDR, it will pipe it to the graphical interface, the GUI, but look, it will also save that into a file, right? So here I've got it saved to /temp/record. So if we press play this time, push the button and stop. All right, it should have saved that into a file. So who can guess what the next step would be? If someone can answer, they'll. Yeah, so we would take the file source this time. So we saved it into a file. We'll take that as a source and we'll pipe that into the Osmocom sync, which is the SDR. So if I disable these for now, let's enable these ones. Actually, let me change that to. So we have the same options set up, so the same frequency that it's going to transmit on, the sample rate is the same, etc. Now this makes me nervous. Will this work? So now hopefully, if I press play, it's just taking the same data that we recorded, and it's going to just transmit it straight to the air. You'll see that because I didn't add the GUI sync, that's why the graphical interface didn't show up, and I panicked. You couldn't tell, but I panicked, just because I forgot to enable that. But it doesn't matter because it's still just taking it, and then in this case, I run it again, but we'll pipe it to the graphical interface and the Osmocom sync, and you'll see there was a spike there. That's what's being transmitted. Right? So does that make sense? We've taken the file, we saved it from the air, and then we just spit it back out. Ideally, what you'd want to do is be a bit more careful than what I'm doing, because imagine if the moment that I hit record on the SDR, imagine somebody with the ICD pushed the button to say like, change the setting or whatever, and it was on a very similar frequency. Well, I did no filtering here. So in theory, we could have transmitted anything else that happened during that recording period. So just a heads up, if you are doing this, you want to be a bit more careful and maybe try to filter for the things exactly. Distance device the most important factor? That will be a big factor, yeah. The SDR, this one here, unless you set it up differently, it's not going to transmit like in a massive range, but you can get amplifiers and things that will help with that.
I mean, for example, in this room, there's probably still some quite strong signal from laptops.
So, I mean, it really depends on the device. When we looked at the Tempest thing before, when I tried it, I had to be like within inches to the device to actually capture the data. But with different hardware, you could be meters away. It also depends on like the building that you're in, because the radio frequencies could be like absorbed in different places, and it depends on like where you are in relation to the person. So yeah, it all just depends on like the strength of the thing that's transmitting and what your antennas and your equipment, so what you can receive. The type of stuff that I do, because it's when I'm doing a security assessment or something, I have the device, I'm quite close. It's less of a problem. But yeah, as I mentioned with the dump 1090 stuff, so with the aircraft, the aircraft is obviously way up in the air, and we're able to capture that with something like this quite easily. And obviously we're not like that close to the device. So did that answer your question? Yeah, cool. Yeah, cool. One thing I do want to show you quickly is So how long was I recording that signal for? Right, a couple of seconds, right? It was while I pushed the button and that was basically it. And you'll see how large the file is, right? 400 megs just from like recording for a couple of seconds. So, a lot of data is coming through this device. And that's related to the sample rate. If we change the sample rate, there'd be a lot less data that's being captured, so the files will be a lot smaller, a lot easier to process, but we'd be capturing less data. So we have to be a bit more accurate about the frequency we're capturing and things like that. So just an FYI. The sample rate, you want it to be as low as possible because it's a bit easier to process the data. But if it's too low, you're going to start to like miss certain things. Is that what I wanted to show on this? How much time left do we have left? 10 minutes. Okay. All right, let's go back to the talk. I'll try and rush through the next bit because I want to show some more about like how we actually analyze the signals, right? So when we're looking at kind of basic protocols, like something like this, there's like two main types of ways that data is transmitted. On-off keying is the first one. So that's basically where data is encoded in the amplitude of the signal. So what it will do is it will send nothing, and then when it wants to send a 1, it will send like a loud data. And then 0, it will send nothing, and 1, some like noise. So data is encoded in where the data is sent or isn't sent. And that's how you will send a 1 or a 0 over the air. All right, so that's called on-off keying. And it looks like this. So maybe this isn't easy to understand right away, but you can think of it like as through time is up and down. So we can see that whatever device this was, it sends a load of like 10, 10, 10, 10, and then a few zeros, and then some 1s and some 0s, right? And it's encoding that data in the like impulses. And then the other kind is FSK, frequency shift keying. And this is where something will transmit on 2 different frequencies. On one frequency would be a 1, on the other frequency would be a 0. And it'll switch between those to transmit 1s and 0s. There are lots more, so yeah, it looks like this, so you can see it kind of jumping backwards and forwards between 2 different frequencies to be a 1 or a 0. There are lots of different types of ways to encode data using radio. These are just 2 very simple ones that you will tend to see. So let's try and show that. So we captured the data from the doorbell. So let's see if we can actually turn that into 1s and 0s. So I'm actually going to use, so I captured this last night, file 2. Basically, file 2 is just what we saw before. You're just saving the data. And if we just scroll across, hopefully. So here, right? So this is what the doorbell button is sending. And what we can probably see is it actually sends quite a lot of data, right? Now, we can see this is on-off keying because it's just sending like a pulse and then no pulse and then a pulse and no pulse to be 1s and 0s. But if you notice, so it goes pulse, no pulse, 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 no pulse, no pulse. If we keep scrolling across, it's actually sending the same data lots of times. So whilst it might look like it's actually sending a lot of data, it's not really sending much, right? Now, what's probably happening here is because these devices are quite cheap, there's no like 2-way handshake or anything. So it's just sends the same data loads of times, hoping that at least one of them will be received by the doorbell. So we want to turn this into like 1s and 0s, because once it's back to 1s and 0s, like it's a lot easier to try and figure out like what's going on. And if this was like an alarm system, for example, maybe we want to try and figure out how to disable that alarm system. Or if it's something more complicated, we can figure out like how to actually go about communicating with it. So the first thing that we want to do here is we can add Amplitude Blocks. We know it's using OOK, on-off keying, which is based on the amplitude. We can add a threshold plot. And what we have here at the bottom is like 1, 0, 1, 1, 0, 0. Yeah, can people see that? Yeah. So this is basically what is transmitting through the air. So with this tool, it's called InSpectrum, if I didn't mention. You can actually tell it to like, this is where one symbol is. So this is a 1 or a 0. And this is the next one, and this is the next one. And so if we just do this, and make sure that it like lines up properly. And we probably want it to be like a multiple of 8, because it's going to be sending bits, right? And it's obviously 8 bits in a byte. So now we've told it like, we want to know what these things here are. So if we right click and if we extract the standard out, that will just basically put those bits on screen. So 1, 0, 1, 1, 0, 0, 1, 0. Now these are the bits that this doorbell button is sending over the air. What we could then do, convert it to hex maybe, and we'll be able to actually see the hex values that it's sending across. I have 2 doorbell buttons here, so maybe we would actually want to compare the 2 of these to see like how it knows. So if I push this one, this doorbell rings. If I push this one, this doorbell rings. Like what the difference is between these 2 things. Maybe if your neighbor has the same doorbell, you could, if you know what your one is sending, maybe you can try and like brute force the ID, presumably this is some kind of ID, and get your neighbor's doorbell to ring and things like that. So this is like a really easy way to pull out the 1s and 0s from the signal. Now you can forget all that because there's actually a better tool, or a tool that makes this a little bit easier. But it's good to know how to do it manually, right? We want to be able to see the signal. But if we look at this thing called Universal Radio Hacker. So this is a kind of a newer tool. When I first started doing SDR, like years ago, we only had GNU Radio Companion. And yeah, to create all these graphs for like very basic things. But now we have tools like Universal Radio Hacker, which helps a lot. So if we load in, which one do I want to use? I think file 2 was one we were just looking at. It automatically, so it shows you the signal that is that we saved. It shows you the signal, and again we see the doorbell button actually sent loads of things, but it's all the same, and it's automatically giving us the bits that's going through the air, and we can kind of easily display this as bytes. So these are the actual bytes that when we push the doorbell button that's being sent. Now, the next thing we'd want to be able to do is modify that, right? So we did a replay attack, which is great, but if we want to actually change the data that's being sent, or if we want to, like maybe we push a button and it's like, do this one thing, we want to perform some other action. We want to be able to change these bytes that are being sent through the air. In the past, I used to use, did I bring it with me? This here. This is called a yardstick one. This is very similar to that IME toy that we saw at the beginning. So more of a software configurable radio. And with this, you can basically say, I want you to transmit these bytes on this frequency using this, this protocol, so like FSK or OOK. And then it would do that. And they made it really easy. So I could use the HackerRF to capture data and then analyze it, and then the Elastic one to actually very easily, like say, transmit these bytes over the air. But we don't actually have to use that anymore because of this tool here. So if we look at, so yeah, like it has all these different tabs to do. So these are the data that it captured. If we look at generator, if we can display this as hex, if we want. We actually have a way to like, this is what it captured, and we can modify it. So I just removed that first line. If I wanted, I could change this from like C8 to a C9. So we can modify the data that we initially captured, and we start to play around with the device. Then if we want, we can, tell it to use the data we captured. I mean, this might not work actually. I've not tried this before on this particular thing. So, but we tell it to use the data, and then we tell it to send the data. Right. So you can see we've taken the original signal, we've demodulated it into bytes, we've changed those bytes into different things, and then we tell Universal Radio Hacker to use the HackRF. We have to give it the frequency we captured on, which was 433 megahertz. We tell it what the sample rate was, which was, I believe, 10 megahertz when I captured this. And then if it hits start, so again, this is a very simple demonstration. It's just the doorbell. But what I've shown here is that we're actually able to, if we wanted, we could modify this. If we modify it enough, we would get this other doorbell to ring if we wanted to. But there's no need for that now. Any questions about that? Cool. So I think we're basically out of time, right? Just to finish up then, we won't talk about some of these common protocols, but there are, there's flaws in things like GSM. So this is like 2G, basically. That would allow someone to, view phone calls and text messages and stuff. There's Bluetooth issues with pairing and keys and blah, blah, blah. You can read about some of those things if you're interested. So basically with SDR, in the past, looking at radio stuff, you'd have all this equipment, all different radios doing all kinds of things. Whereas now we have, one device with our laptop and everything's happening in software, and it's really easy and cheap to attack these things. Okay, that's it.
I'm just gonna wait for this to turn on.
Sure.
It comes on after a while. It just takes one of these days. Yeah, sure. Just keep. I've got nails too. I know it'll turn on. I am determined. Not charged. It is charged. There you go.
Right. Sorry, I got a couple of SDRs. I think you asked me a question, right? One of you asked me a question? Right, you can have to take one of these if you want.
Go on, then.
John?
Could you tell me the name of the software?
So on Linux, GQRX. Yeah.
Could you tell me the name of the software you were using and if there are equivalents for Windows?
So do you mean the first bit of software we saw where we could tune in? Yeah, so that was GQRX. On Windows, there's SDR Sharp. There are other software as well, but they're the two that I tend to use. Very good place to start because you can tune in, look at different frequencies, demodulate like the voice stuff really easily, and some data as well. So like with FM radio, it also transmits like information about the song and the station and everything. And with like SDR Sharp, it can demodulate that and tell you all that stuff as well. So.
Right. Does that answer your question? Right. Does anyone else have any questions for Jay? Yes.
By the way, I've got a few other things here if anyone wants them. So I've got a, has anyone seen like the rubber duckies from, yeah, so this isn't quite a rubber ducky, but it's a very similar thing. You plug it in and you can program it to basically send like keystrokes to a laptop. It's programmed at the moment with just a payload that I think just opens up the DI website if you're on Windows, but nothing malicious. So if anyone wants some of these, I've got quite a few. And some stickers as well if you want them.
A couple of questions for them.
Sure.
So if you're in a very noisy environment, how do you isolate the signal you're looking for?
Good question. You try to not be in a noisy environment first. And that's like one of the issues I have when I'm doing this kind of talk. I have no idea what the environment is going to be like. It helps to be close to the device. It helps to know which settings to use. If I'm doing something that is particularly risky, you can use a Faraday cage to block everything else out. I've used old like microwaves in the past because they obviously shield like certain frequencies. Tin foil I've used as well. That's pretty good at blocking out. So if you use enough of it, you can buy Faraday cages or build them. So anyone that's doing like a lot of this work will have that kind of environment. Helps them to stay within the law. It's not always legal to transmit or receive things that you're not supposed to. And it stops like other things from like interfering. And then the other thing you can do is actually within software, you can filter out the things that you're not interested in. So if you know that this transmits on a certain frequency and you know where it is, you can actually apply filters in lots of the software we've used to just block out everything else and just focus on that one thing.
Thank you very much. Anyone else with any questions?
That was a good question, by the way. Do you want one of these? So this is the Rtl Sdr. Was that yes? That's my last one, I'm afraid. But they're just a tenner. You can buy them if you're interested. They got them from Amazon.
Right. Ryan, did you want to ask something?
Yes, someone behind you wants to ask a question.
So if you use an SDR, right? Would the TV license people never ever catch you?
It's not really their kind of realm. Like, do you mean if you're just using it to watch TV?
Yeah, basically.
I don't think they will catch you. But I don't think they can catch you if you're just using a TV anyway. Like they say that they have vans driving around, but I've never seen one. I think that's just a rumor that they started to scare people. So yeah, but you can use a lot of these techniques to track people and to track radio signals. So like if you're interested in that kind of side of thing, like this is definitely an area to like look at. There was a talk by someone called what was her name? Melissa. I forget her surname. She spoke at I think DEF CON a few years ago, and she was able to like everyone has different devices on them. So when I go out, I've got my phone, these headphones, a few other things, and that's like a kind of a fingerprint for me because no one else is really gonna have this combination of devices. And she was able to say like, oh, this is what this person looks like in like radio. And this is what this other person looks like in radio because they've got a different combination of devices and they could like track them around using that, which is pretty cool. Bit of a tangent there, but you reminded me.
Two quick questions. First, going back to.
Yeah.
First off, back to when you were talking about listening to radio signals off cables and stuff like that. Presumably you can do this for like laptops across the room and stuff like that. If you've got really sensitive, if you've got a company that, there's a lot of sensitive information and they're working somewhere, are there workstations that have mitigations in place for this to stop you from capturing keystrokes and image and stuff like that?
So I don't know if there's specific workstations that protect against this type of attack. I assume there must be, like before, highly sensitive things. I do know that some buildings, they will have like a secure room where work happens in when they are worried about this type of attack. But then I remember this one case where I think there was like a pipe that went into the room, and then that was kind of acting as like a antenna and allowing people to like still like do tempest attacks and stuff, just through this pipe. So
having it bounce off the waves.
Yeah. So
second question then, how on earth do you build your own Faraday cage?
so it depends on what you're trying to what frequency you're trying to block out, but I mean generally you just want something that blocks out radio signals. So as I mentioned before, like tinfoil can actually work. I built one, just a load of tinfoil around the devices that I wanted to look at, put them in it, and it was fine. I'm sure there are other designs, like it will be depending on like the width of the the gaps between the devices and stuff, because different frequencies will go through different gaps and things like that.
Thank you.
Or like, as I mentioned, like a microwave can
Can do
Yeah.
the same thing, yeah.
Hi, you're earlier trying to connect your SDR to the mic. Can you listen to whatever the person is saying in the other room if somebody's talking on the mic?
Yeah. So actually, I gave this talk at a conference before, and I did that as like so before my talk, I recorded something from the room that was like a completely different event. That someone was giving a talk, I recorded that, and then in my talk about SDR, I actually replayed that, or like, played the audio. The other thing you can do, if these devices aren't encrypted, which a lot of them aren't, you can do the replay attack, right? So if somebody is up there talking, you could actually take over the speakers and play different audio or whatever. And we saw how easy it is to do a replay attack.
How do you keep up to date with the legal implications of what you do, and like how does that affect the scope of what you're actually doing?
So there are certs that you can get. So like what's it called? Slips my mind, but yeah, there's a cert you can get to like allow you to do radio things. Otherwise, it doesn't change that often. And then like finally, I guess, just be really careful.
Any more questions?
Right. Manchester Grey Hats. What's coming up?
Good question. Like as I said, with Manchester Grey Hats, we run like all kinds of workshops and stuff. So I've done this as a workshop where we actually do the exercises, stuff on Frida, all kinds of hacking things. Basically, if there's like a new thing that I'm interested in, I'll turn it into a workshop and show people like how it works. But yeah, we stopped at the start of COVID. We don't really know when we're going to start back up. Probably soon. Now things are kind of opening and people are feeling a bit more comfortable. But if you keep an eye on our Twitter, if people are interested, that's where we post. We're on Meetup as well. You can follow us on that. And then when we do an event, we'll put posting on there.
Right. If there are no other questions, thank you so much, Jay Harris from Digital Company. Thank you very much.
As I said, if anyone wants to grab one of these things, you can come and grab them. You can program them, as I said, to act like a keyboard. So the idea is if you see someone's laptop unlocked, you can plug it in quickly and it will like type for you, and then you can.
We can use them for like Q&A later.
Yeah.
That's all right.
Yeah.
Thank you so much.
Welcome.